using 2 steps to solve an equation with whole numbers. So it's telling you right away there's going to be 2 steps, and we're going to have whole numbers in it. So it is warning us that we're going to have whole numbers. We're not going to have decimals, which is nice, but it's also letting us know we're going to have 2 steps to finish this. So if you look at 86 equals 4y plus 10, what we want to do and what they're showing you down here, I tend to stack it a little differently. You'll see this on the next page. I can actually write over here. So I have 86 equals 4y plus 10. So I tend to stack it a little differently. So instead of putting it in the equation like what they're doing right here, what I do is I write it right underneath. So I want to get this variable all by itself. So I want to start moving things away from it. And by away, I mean I want to get them on the other side of the equal sign. So here's our equal sign, right? So I want to get those on the other side of the equal sign. So I want to take this 10 and I want to bring it over here. In order to do that, I have to do the opposite of what's being done with it. So if it's being added, which it is, I have to subtract, like this. So that's why they subtract, and they're calling it undue addition. It's the same thing that I'm saying, just in a different way of saying it. So we want to do the opposite so that we can undo it and bring it to the other side. And remember, equations are like a balance. So if I subtract 10 from one side, I have to subtract it from the other side. So if I subtract 10 here, I get 76 equals, the equals and the 4y just come straight down. Nothing has happened to those yet. But positive 10 minus 10 crosses off, which is what we wanted to happen to those. We wanted them to go away. So now, because I'm still trying to get that y by itself, I want to take this 4 and I want to put it on the other side, again, of that equal sign. So I do the opposite of what's ever being done so that I can undo it. So again, they tell you here, undo multiplication, because 4y means multiplication. To undo multiplication, I divide. If I divide one side, I have to divide the other side. So now I end up with 19, which they nicely did the math for me right here. And then 4 divided by 4 is 1, not 0, because we do want the y left over. So when we're adding and subtracting, we're left with 0. I didn't write the 0 here because we don't need to. But when we divide, we're left with 1. So 19 is y. So y has to be 19 in order for this sentence to be true. That's basically what we're trying to find, is what does the variable have to be in order for the equation to work out correctly. All right, let me erase this so we can start a new one. Okay. All right, so we have u divided by 5 minus 12 equals 7. For whatever reason, when students see this, they're immediately put off by it. They really don't like seeing fraction. Remember, fractions are just division. That's all it is. So think of it as u divided by 5, like this. See how it kind of matched perfectly on that division sign? It's just another way of writing division. That's all fractions are. All right. So I'm going to change my color here. Okay. So remember, we're trying to get this u all by itself. Whatever the variable is, it doesn't matter what the letter is. We're trying to get that variable by itself. So what we want to do is move everything else away. And I didn't really mention this on the example, but we do want to start with addition or subtraction first. Mainly because if we try to start with this 5, to undo division, I have to multiply. But if I start multiplying, I have to multiply this and this and this. I have to remember to multiply each piece. And it just creates a little bit of a mess, especially in a division problem when we're dividing. So instead, if I undo addition or subtraction first, it simplifies the process. So in this case, I have a subtraction because I have minus 12. So to undo that, I do plus 12 and then plus 12. Remember, it's always across the equal sign. Here's your equal sign. So the two, one should be on the left, one should be on the right when I say plus 12, plus 12. You should never be adding them to the exact same side. All right, I'm going to draw my line like I did before. u divided by 5 is just going to drop down. Nothing has happened to those. The 12, negative 12 plus 12, cross out. Because anything positive and negative, the exact same number, that is 0. It always cancels each other out. And then we bring the equal sign down. We have 7 plus 12, so we get 19 there. All right, so we already kind of talked about this. This is division. We're always trying to undo what's being done to get this variable by itself. So in order to undo division, we multiply. If I multiply the left side of the equation, so the left side of the equal sign here, if I multiply by 5, I have to multiply by 5 on the right side. And so then with this one, because if I have multiply 5 and I divide 5, those cancel out. And I have just u. Technically, there's a 1 there, but you do not have to write 1u. And in fact, the system will tell you you don't have to write the 1 in front of it. So then we have this on here, and we have 19 times 5, which we should get, I believe it's 95. Yes. All right, so we get 95. So u is 95. And we're going to click check. Ta-da! Yay! All right, one more of these. Okay, so we have 37 equals v divided by 3 plus 13. Again, remember, fraction is just a fancy way to write division. So keep in mind, we're always trying to get the variable by itself. It doesn't matter if it's on the left side of the equation or the right side of the equation. That doesn't matter at all. We're just trying to get this v by itself. So we're going to start by undoing addition and subtraction first, because again, that does simplify the process. So if I'm adding 13, I'm going to subtract 13 from both sides of the equal sign. I'm drawing that line just to make it clear that there's two sides. There's a left side of the equal sign and a right side of the equal sign. All right, so we have 37 minus 13, we get 24 equals, we're just going to bring v divided by 3 down. 13 minus 13 cancels out. Okay? So now we have v divided by 3 on the right side here. Again, we're trying to get this v by itself. So we have to undo the last piece that's being done. It's being divided by 3, so I have to multiply, because to undo division, I have to do multiplication. And then whatever I do to one side, I have to do to the other side. So since I'm multiplying by 3 on the right side, I have to multiply by 3 on the left side. All right, so 24 times 3, we get 72. 24 times, whoops, 24 times 3, yep, 72, equals any number divided by itself cancels out, which is why we do that, so that we just have the variable left over. So v has to be 72 in this case. All right, that's a whole nother topic, all done.